Arcade. I'm using a new microphone today, so if you could tell me how my voice is coming through. Is it sufficiently loud? Is it too loud? Is it, does it sound pretty good? So I can adjust the gain in OBS if I need to. Mr. Pine. All right, so how's the audio coming through, those of you guys who are online? Anyway, just let me know if I need to turn up the gain. I don't want to sign in. Dang it. Okay. All right. So here, let me just go on Twitch and tell them. Well, there's a little hole in the side. It's this guy. Yeah. So, yeah. Okay. Okay, well, so let's get to it then. So what I wanted to kind of start talking about today was the tic-tac-toe game, which will kind of answer some questions or things that a lot of you guys have had, namely what to do about things like, okay, so some of you guys wanted to do like sort of a Pokemon-y style game where you're in or Zelda or something where you're in an overworld and then you get into battles of some sort, and in the battles, like in Pokemon, right, what is there in Pokemon when you get into a battle? Yeah, and it's turn-based. There's an enemy that has some sort of life bar, or enemies, perhaps, like, say, in Final Fantasy. There's whatever Pokemon that you deploy. But there's also a menu of different options that when it's your turn, you can fight or try and capture or whatever, right? And so you have to have a selection system. Well, there's not just like a magic menu thing built into MakeCode. I suppose I could probably sit down and write one, but there's not a magic thing built in, and so what we'd have to do is kind of roll our own menu or selection system of some sort. Well, doing that is actually going to be somewhat similar to doing the tic-tac-toe problem, because in tic-tac-toe, you need to basically select which of the tiles you're going to change from being blank to either an X or an O, depending on whose turn it is, right? So, in a sense, they're very much similar problems. Okay, now, there's a couple different ways to perhaps solve a menu. And so the way I'm going to at least start doing the tic-tac-toe thing, we'll see if it's a good idea, is maybe slightly different than the way I would do a menu, or a way I might do a menu. But anyway, so let's kind of get to it. Okay, so the first thing that I needed to do, and I went ahead and did this part in advance, is, yeah, Kate, I've got that set up so that I don't get like spam and stuff all over the channel when I'm streaming. So the first thing I did is, well, we needed some assets, right? So if it's tic-tac-toe, I need an X and I need an O. and I need a blank tile, which I made just the black border there. And then I also need something to kind of tell me which one I'm currently on, for like to choose whether or not I'm gonna, which tile I'm currently at. And so I did the same thing as the blank one. I just made it sort of this yellow background to sort of like a highlighter or whatever, okay? So no big deal, right? These are all 32 by 32 sprites, and I just made them that big because it seemed like it would fit decently on the screen. The size obviously is, if you were making a menu, it might need to be a little different or something, but this seemed perfectly fine for example's sake. Okay, so nothing special about the assets, they're just images. And then what I started doing, although I'm not finished with it obviously, is I need to generate all 9 game tiles, okay? And I need to, so far I've only defined basically 3 of them. And then the way I'm thinking of the gold tile is that it's actually the player, and so it will be movable with the keys when we add that functionality. But at the moment, there's nothing there to move it. Okay, so what I need to do is I need to basically just duplicate what I've got here to create the other 6 tiles. And I went ahead and futzed with it to get it right. They're 32 by 32 wide, and so I had to kind of do the math to figure out, all right, where's the center of the screen? How far to the left and the right do I need to do? What's the offset for these things? So the X values that we need for them are 48, 80, and 108. Okay, great. And then for the top row, the Y values are all 28. Also great. So what I can do, right, is just, I think, is there a way to select multiple tiles at once? Yeah, oh well. Okay, well, I guess we'll have to do it one at a time. That's sort of unfortunate. But, so, I mean, this part, right, is nothing special. And the only difference, of course, is that, actually, you know what? Let's be really smart about this. What about if we make a function that inputs a Y value, and then I could just call the function a couple of times? Let's do that. Okay. So let's do a function, and I want to make a function that's called make row of number. Yes.
Can you please explain what you're doing right now?
The function part?
No, not just like creating the function, but like what is this going to do?
Oh, so okay. So I need to, if I'm going to have tic-tac-toe, right? I need a 3x3 grid of things, right? And so I've made each individual grid entry is just one of these blank black boxes to start with, okay? And so the first thing I need to do to have a game is to have the 3x3 grid. Right now I've made the top row with that little set of blocks, but I need to make the middle row and I need to make the bottom row, and I just haven't done that yet, okay? So to make the middle and the bottom row, right, I would just duplicate what I've got here, but then shift them down to the appropriate Y level, okay? All right, so I'll just duplicate it. It's not the most elegant solution, but it'll work. All right, so this is tile 4 position. Okay, so the Y value for this guy, I need to add 32 to it because it's one further row down. So that's going to be at Y value 60. And then when it refreshes, we should see, yeah, okay. And then just so that I'm doing these in order, I'm thinking of my tiles as 1, 2, 3, 4, 5, 6, 7, 8, 9, right, just in order. And so I'll just do them in that order, okay? So I need the 5th tile, and he needs to be a sprite of kind tile. His position needs to be 48, comma, well, not 48, but 80, because he's the one in the middle. Okay. Now, it doesn't look like there's anything there. Why? Yeah, because the order I chose to do this in was to make the tiles and then put the yellow selector tile on top. And so there is a black tile underneath that gold thing, but you just can't see it because it's underneath, okay? And I just chose to do that because it makes sense that the selector should be right on top of it so that you can tell what you're looking at. Okay, so just need to keep going and make a few more. This part's kind of boring, but you know, you got to do it. All right, and then the horizontal position for this one was at 108, and I made it tile 6, so we're good there. And that's interesting. Looks like I may be off on my math somewhere because that gold block shouldn't overlap like that. It's either that or I didn't put it at exactly the right position. So let me change that real quick. So let's say cursor sprite, and let's put it at 80, 60. Okay. 32 by 32. Those are 32 by 32. Oh, maybe I just didn't make the border as thick. Let's just edit that real quick. Let me make the border 1 unit thicker. Because we want this to look decent too, right? Still off. All right, well, whatever. We'll futz with that later. Okay, so so we just need to do the same thing for the bottom row. Okay. And for the sake of just the demonstration here, I won't bother with the bottom row right this instant. Let's kind of move on to the next issue. But making the bottom row, same idea. Okay, we just need to copy and paste basically. Okay, so I need to do that. I also need to figure out then, how do I move my sprite? How do I move the gold cursor? Well, how did you guys move the cursor or the player in either the spaceship game or the simple platformer? Yeah, you use the buttons, and there was a thing in here under controller which was move my sprite with buttons, right? And it just magically worked. And so if I throw that in here, something like this, and then go into the simulator. Oh, right, to cursor sprite, thank you. Right, then I can move the thing around. Okay, and that's fine for making a player character that can move around in the world, but what's sort of the issue here, potentially? Yeah. Yeah, I needed to kind of snap to the grids because what I want to do later is make it so that when you hit like the A key or the B key or something, it select whichever tile you're on, it changes that to either the X or the O depending on whose turn it is. Okay, so the using the arrow keys to move, there's nothing wrong with that except I want it to snap to the individual grids. So I'm not going to use that one. We're going to have to roll it ourselves basically. Okay. And what we're going to have to do is use under controller, we're going to have to use basically 4 of these things for up, down, left, and right to basically say, okay, are you allowed to move left, say, and if so, how far do you move when you press the arrow key once? okay? And similarly for up and down and right. Okay, so we'll have to do kind of some thinking here. So let's do the left arrow first, right? There's no necessarily different order that we do it in, okay? Where is our gold object right now? What's its position? Yeah, it's in the center, which is x is 80, y is 60. Okay, so that's sort of our beginning position in the game. Okay, and so if I move to the left, what's the smallest my x-coordinate can ever be? Yeah, x-coordinate has to be either 48, 80, or 108, right? Exactly one of those three numbers, okay, because those are the x-coordinates of each of the three tiles. Similarly, what about the y-coordinates? What can those be? 28, 60, and not 108. It'd be 92, right? Because it's 60 plus 32, right? Okay, so, right, so that's what we need to basically program, is that the left arrow key, if, so then we'll go into logic and we'll say, well, actually, let's do just this one. Okay, if true, well, under what condition are we allowed to move left? Okay, say that, but in math, not English. Yeah, in terms of like its x or y coordinates. Okay, keep going. And under what circumstances are you allowed to move left? Can you move left if your x-coordinate is 48? No, because you're already on the leftmost column, okay? So what should we use as a check for whether or not you're allowed to move left? If your current x value is, say, 60 or bigger. Does that make sense? Okay, so what we'll do, right, is say, okay, so we need a math block because, or sorry, not, it's under logic, that's where the comparisons are. So we need one of these guys with a greater than or equal, okay? And that's what I'm gonna plop where it says true. Okay, so you notice that, you see how that the little socket is sort of got pointy ends on it, right? That tells you its data type. Okay, so this language, like Scratch, I do like how they kept this. The data types are roundy things are like texts and numbers, and pointy dudes are things that can either be true or false only. Okay, so we call those Booleans after George Boole, who did a bunch of this math back in the 19th century. Okay, so what thing has to be bigger than or equal to 60 in order to move? The player's x-coordinate, okay? And so what is the player's x-coordinate? Well, this would be, where is it? This guy right here, okay? So this object, not my sprite, but rather cursor sprite x, and I'm gonna plop that into the little roundy dude there. And so if the cursor's x-coordinate is bigger than or equal to 60, that means I'm either on the second column or the third column, and I can therefore move to the left. Okay, does that make sense? How do I move to the left? How much should I move to the left? I should move by 32 units to the left, and so what I'm going to do is under sprites, I'm going to choose change cursor sprites x-coordinate by minus 32. Okay, why minus 32 as opposed to 32? Because it's going left, okay? And now when I do this for the right key, it'll be positive, right? Okay, and so under the circumstances that the x-coordinate is bigger than 60, then I can move left, and I move a discrete amount 32 units, and that keeps me lined up with the tile, well, possibly subject to my art. I probably messed up the art somehow, but you guys get the idea? Yeah, okay. All right, so let's test it out. So if I hit the left arrow key, okay, I moved one spot to the left, but now what's the problem? I can't move anywhere else because I haven't defined what to do when I hit up, right, or down. And I certainly can't move any further left because I'm already at the leftmost position. Okay, so does that make sense? All right, so what we got to do basically is duplicate this dude and tweak it for up, down, and right. Okay? All right, so let's do right first, since we've already done one horizontal direction. Okay, so I'm just going to duplicate that whole chunk and make this on right button pressed. Okay, now, how do I know I can move right? Less than 108, but another way to say that would be less than or equal to 60. Okay? I can only move right if I'm on the first column or the second column. Well, both of those have the property that my x-coordinate is less than or equal to 60, because it's 60 on the nose when you're on the middle column. Okay? So then I just change it to, well, moving right, what do I do to my x-coordinate? Instead of subtracting 32, I want to add 32. And so that's it for the right arrow. Okay, so let's test that one and make sure it works. Okay. And refresh. Left works, right works.
Actually, it seems like your middle x position is 80, so it should be that.
Oh, wait a minute. Yeah, you're right. I'm sorry. Okay, this should have been 80, not 60. Because 80 is the middle in the x direction, 60 is the middle in the y direction. All right, so let's try that again. Yeah, there we go. And I think maybe I did some arithmetic wrong, because what should, this grid just doesn't look right. 80 minus 32 is 48, correct? And 80 plus 32 is 112, not 108. That's why it doesn't look right. Because I can't do arithmetic. That looks better. Yeah, okay. You'd think I'm like a mathematician or something. Yeah. No, this is what I tell my guys in calculus, right? If I wanted to be good at arithmetic, I would have gone into accounting, right? Mathematicians are in the business of thinking about like higher things than mere values of numbers, right? So, like, for example, what was the worst day of math for most people? It happened probably sometime in middle school, early high school. You're in math, there's numbers, everything's cool, and then what happens? The alphabet shows up, right? And that's the worst day mathematically for most people. For me, that was the best day. Yeah, so anyway. Okay, so we got that fixed, that's good. Now what else do we need to do? Yeah, we need to do the same sort of story for up and down. Okay, except that moving up and down, what coordinate do I care about? The y coordinates. And just to keep us on our toes, how do the y coordinates work? They work backwards from the x coordinates, right? So going down is actually positive y, not negative y. Oh, that's fun. Okay, so if I want to go up, then my y coordinate needs to be what? Okay, so what is the top row's y coordinate? 28. What's the middle row's y coordinate? 60. Okay, so what I need is that my y-coordinate needs to be bigger than or equal to 60. Okay, because that means that I'm on the second or third row. Okay, yes? All right, and now, if I'm permitted to move up, then what should I do to my y-coordinate? Change it by negative 32, because remember, up is down and down is up in our coordinate system. Okay, so let's test this one. Left, right, those are Gucci. Up is Gucci. Left and right are still Gucci, but I'm just missing down. Okay, all right, and so down, same deal, except I need to change this to down, this to less than or equal to, and that to positive. Okay, but other than that, everything's the same. Okay, good. All right, so we're Gucci. All right, so let's test it out. Make sure it works, and then, yes, question?
Is Y for like the left and right button
Mm-hmm.
change the X value to 80, like from 60 to 80, but then when we
Why
go
is it
down,
60 on the Y? Because the screen isn't square, right? So the middle of the screen is X60, or sorry, say that backwards. X is 80, Y is 60, right? And because the square is a rectangle, not the square is a rectangle. The screen is a rectangle. So when I had 60 earlier, that was a mistake for the X directions. It was just me being a bonehead. Okay. Yeah, 80 and 80 for the X directions, which, let's double check that it is, okay? And 60 and 60 for the Y directions, okay? Yeah, and that's just because that's what the size of the screen is 160 units wide and 120 units tall. So it's a 4 by 3 ratio, I think, yeah? Yeah, so, which that ratio, 4 by 3, was the, until the mid-2000s or so, was pretty much any screen that you bought was a 4 by 3 ratio. Okay, so if you went out and bought a TV, they were all 4 by 3. And it was about that, like I said, the mid-2000s, correspondingly with a shift to LCD displays. They were finally, coming down where they weren't outrageously expensive. That stuff has switched to either a 16 by 9 or a 16 by 10 in some cases ratios. Okay. Yeah. Anyway, so but since this thing is sort of a classic old school Game Boy, they wanted to go with the same aspect ratio that the old Game Boys used, which was a 4 by 3. Okay, so now that we've got the down button pressed stuff in, let's try it out. And yep, no problem. I can move all the live long day. And the only problem, of course, is that, well, I just haven't put the blank grids down on the bottom row, but that's really just copying and pasting. Okay, good? Okay, so we've got the movement part figured out. And this would be kind of the same, like if you wanted to have a menu, you could use something like this. All right, now in Pokemon, how is the menu laid out when you get into a battle? Is it 4 items vertically, or is it like 2 rows of 2? 2 rows of 2. Okay, so you'd use something sort of like this if you were doing like a Pokemon type thing. Let's say that I wanted to program like like one of those tile matching memory game type things. Where everything's hidden and you get to uncover a thing and you want to match it with another thing, right? Then same idea, it's just I might have more grid spaces or something, okay? And the fact that I made my grids 32 by 32 was just because, right? I mean, they could have been any size that I wanted, okay? Okay, so got the movement down. Now what? Well, what else do we need to worry about in tic-tac-toe? Lots of things. Yeah, I've got to make it so that if I'm on a blank space and I hit, say, the A key or the B key, whatever, then it's going to convert that space to either an X or an O. And how do I know it should convert to an X versus an O? Yeah. Yeah, whose turn it is or which player is doing this, okay? So, and so I'd probably want it, in our case, to alternate between player 1 getting to move and player 2 getting to move. Now, there's two ways I could handle the multiplayer part here, right? One would be to actually program a second set of buttons for the other player, okay, using this sort of multiplayer type stuff. The other would just be to have the turn alternate each time you select something, okay? I'll do the latter one just because it'll be a little less code, okay, for now. But, you know, we could have done it the other way, right? Okay, so if I want to switch a tile from a blank to an X or an O, there's a couple things I need to double check. First is, am I actually selecting a valid tile? Meaning, I can't pick something that's already been picked, right? Okay, so I need to worry about that. And then the second would be, well, I need to know which tile to flip, right? Or which sprite to change. So in this case, right, if my cursor is on that particular tile, how do I know where I am, which tile to flip? Yeah. Yeah. Well, valid tile is problem number one, and which tile I'm on is problem number two, although it's certainly related to problem number one. Yeah, I can do it based on its coordinates, okay? But I could also do the thing where I check the overlapping, right? Okay, so let's go to sprites, and notice I've got on sprite of kind whatever overlaps, but I also have here my sprite overlaps with other sprite. Okay, so I could use that as part of my which button do you guys want to use? A, B, it doesn't really matter. All right, let's use A. Okay, so under controller, I'm going to say on A button pressed, do something. Okay? And I want all of the things that happen here to be related to flipping the tile, also, say, doing the changing whose turn it is, because once you hit the button, the next turn should be the next player. Okay, so the first thing we need to do is check, are we on a valid tile? Okay, which means we first need to check which tile am I touching? Okay, and so what I'll do is let's go to sprites, and we've got, let's see, where was it? My sprite overlaps with other sprite. Okay, so then I'm going to use a logic block, and I'm going to say if my sprite is overlapping with another sprite, okay, and I would be overlapping with somebody, and actually I've guaranteed that I'm overlapping with somebody, right? Because I've made it so that I can only move on the grid. Okay? And then which sprite? Well, I want this to be my cursor. Okay, and then other sprite, well, I don't know who that's going to be yet. Actually, you know what? Hold on one second. Yeah, I want the thing where it gives me the kind. This? No. Oh, okay, that's why. It's because I haven't used other sprite yet that it's throwing the error. Okay. So we just need to add something, right, to it. Okay, so if I'm overlapping with another sprite, first thing I need to do is check, is that tile already flipped to an X or to an O? Okay, how could I check that? Or how could I store that information? I could store it in a variable. All right, so let's go into the sprites and see what, well, hold on one second. I just want to see what things I've got as options here. Oops. Okay, so we'll have to do this numerically, and the reason is there's no way that so I can grab what image a particular sprite is, but I can't say, is it equal to this other image without using an extension. Yeah. Yeah, okay. The only problem with that is that I can't put that inside a button press block, which is why I didn't. Huh? I don't know. Yeah. So, yeah. Now, that said, we could still use that because there is also the is button be pressed Boolean, right? But whatever, we'll just stick with this. Okay, so so the problem is that there's no way that I can check, am I overlapping a tile with this image? Okay, meaning the black tile. Okay, what could I do instead? I could assign some variables to everything. So why don't we say that when you're a blank tile, your value is 0. Okay, if player 1 has flipped you, your state 1, and if player 2 has flipped you, your state 2. Okay, so what that would mean is that we would need the state of that variable, or of that tile, to be 0 in order to flip it. Because if it's state 1 or 2, it's already been flipped. Okay? All right, so we need to make 9 variables. Okay? 1 for each of the tiles. Okay? Now, under, let's see, not sprites, under variables, let's see if this actually works. Nope, won't work. Okay, that's what I figured. Okay, so can I use tile 1 as the variable for the first tile? Why not? Yeah, tile 1 is a different kind of object, right? And I can't mix apples and oranges like that. Okay, so what could I do instead? Yeah? I could. Exactly. Well, it would be, but then I'd have to figure out, okay, based on the coordinates, which object am I at? Which would be more complicated than perhaps I want to do. Okay, would work, but yeah. Okay, what about if instead I just make 9 new variables? Okay, yeah, it is a lot of variables, but welcome to programming. Okay, if I've got tile 1 through 9, I mean, I haven't created the other 3 yet. What about if I call this like space 1 through 9? Okay, or what's another option? Under extensions, there was, where was it? arcade sprite data, this allows me to attach variables to specific sprites, okay, other than their positions and stuff. Okay, so by default, what local variables are there for given sprites? What are you allowed to work with? Okay, let me back up a minute. What's the difference between a local and a global variable? To everything, okay? So an example of the local variable would be the x coordinates of something. Okay, so let me go out of this so that we can see what I'm talking about. Let's go over here to my button pressing stuff, right? Whose x coordinate did I care about when I was working with the movement stuff? The cursor sprite, okay? So x there, whose x is it? It's cursor sprite's x, as opposed to one of these tile sprites' x, or my mother's x. Okay, right? There's everybody gets an x. It's like Oprah, right? You guys are big Oprah Winfrey fans, I'm sure, right? No, I haven't either, but there's memes that have gotten made out of it, so therefore I know it. Like, bees are coming, for example. That was maybe my favorite. Okay, so I care about the x coordinate of the cursor sprite. Now, if I click this little drop down, I can see all the different local variables that are built in and attached to any sprite object. Okay, what do we got? We got x and y, vx and vy for velocity, ax and ay for acceleration, fx and fy for friction, lifespan, width, and height. That's it. If I want to add a variable that's sort of attached to each dude, I need to use that extension to create them. Okay, so the options are create a local variable that's attached to each of the tiles, or make 9 global variables. All right, which way is maybe a better move? What's the easier move, probably, for this example? Yeah, to make the 9. It's quick, we can make them, we just need to name them something non-stupid, okay? But let's deliberately do it with local variables, because that's how you have to do pretty much everything in Unreal Engine, so we might as well just start getting in the habit now. Okay, now, to do local variables, you have to use the arcade sprite data extension. Okay, it's not built into vanilla thing, okay? And once you do that, that adds some dudes down here at the bottom of the sprite menu, okay? Namely to data, okay, whatever. Okay, now you'll notice that there's a whole lot of options here for what kind of data, right? And so really, it's these 2 blocks repeated a bunch of times, okay? But why are they repeated? What kind of data could I have? I can have text, or sorry, sprites, true falses, text, which is strings, numbers, and images. Okay, does that make sense? Those are the data types in our world here, right? Okay, what kind of data do we want to store for our purposes? Huh? We could store images. But the sprite already has an image attached to it. Right. True, false, okay, would be optional. Okay, but let's actually do it with number. Okay, and the reason is because whether or not you've been flipped, yes, is completely true, false. Okay, but what state you're in, there are actually 3 states that we could care about. Unflipped, flipped to X, and flipped to O. Okay, since that's more than true false, let's use the numeric one here. Okay. Oh, actually, you know what? Yeah, okay. No, we'll run with that. That will cause us a problem later, but we'll deal with it when we get there. Okay. Namely, we have to figure out under what conditions does somebody win, right? And that's going to be fun. Okay. All right, but whatever. We'll just go with the number for right now. All right, so when I create all of my sprites, I need to also create data for them. Okay. So I'm going to set this guy here. I'm going to set tile 1's data. What name do I want to give this? I'm sorry? Well, okay, but it's already tile 1, so I don't need to give it a name like that. This is what state that tile is in. Okay, so why don't I just call it state? Okay, and what number do I want to start with it as default? 0, because all the tiles are unflipped. Okay, so what do I need to do with this set tile 1 data state to number blah? Well, before that, you're getting ahead of yourself. What do I need to do for all the other tiles? Same thing. Okay, so I would need to duplicate this guy and put him for each of the other ones, because what state do all of my tiles start in? State 0. Okay. So I'll just do it for the 6 that we've already got in existence, and obviously we could continue this for the other 3 that are missing, but you guys get the idea there. You don't need to sit here and watch me copying and pasting 20 things. Okay, so now each sprite has a variable attached to it called state. Okay, now here's what's sort of maybe, it's both confusing and not confusing. The state variable, you can't just say, what's the value of state? You have to say, what's the value of this object's state? Okay, so everybody gets a state variable, and they could all be different even though they're all called state, because each one is attached to a specific object. So tile 1 state could be different than tile 2 state, could be different than tile 3 state. Right now, they're all starting at the same value of 0. That makes sense. We haven't done anything yet. But when we start flipping tiles, we're going to be messing with those dudes. Okay, does that make sense? Oui ou non? Très bien. Okay, so now let's go back to our B button situation. Okay, if I'm overlapping with another sprite, what's the very first thing I need to do? Check its state and make sure that I can actually do something. Okay, and so I'm going to put another if block in here. Okay, and then I need to do logic and I need equals. Okay, because what am I going to check? I need to check if something equals 0. Right, because to be able to flip a tile, the tile that you want to flip needs to be in state 0. Okay? All right, so whose state do I need to check? The tile that I overlapped. Okay, and so what I'm going to do is I'm going to go in and I'm going to say this one. Okay, and I'm going to plop him here. All right, what's item here? Who is that? It's other sprite. Oops. Okay, why am I still getting an error there?
It's because you needed those other sprite find, and you can set it to both compiled or whatever.
Okay. Okay, hang on one second then. So what we need to do is we need to make other sprite to kind tile. We just won't attach any image to it.
Checking if you actually have something called other sprite.
No, we don't. Oh, that's really annoying that they did it this way. Okay. Right, so what I wanted to use here was other sprite as a generic entry. Oh, that's really annoying. Yeah, but then it's an array of all the sprites of that type. And I only want the specific one. Well, okay, so, because where's the array thingy? Array of sprites, kind, tile. But see, then I would need to do, all right, let me just think here for a minute. Okay, why don't we try this? Create an array. Okay, this is super janky, but I think it'll work. Okay, I think this is going to work. It's, oh no, failed cast on null, of course, the damn null pointer. Okay, we're going to have to go about this a different way. So the problem is that I can't use value here as a generic placeholder variable. Okay, so let's just delete all of that. And, oh wait, hold on. Maybe this was the problem. Yeah, failed cast on null. We'll talk about casting when we get to Unreal. Okay, so what we're going to have to do instead is something a little different, which is, okay, why am I casting on null now? Oh, hold on. Yeah, all right, so let me get rid of this. And now let's see if that works. Hey, it does. Okay, actually, so yeah, so this is super janky, but hey, it'll work. Okay, all right, so yeah, with the other class, maybe I'll do it the other way. And then, of course, excuse me, the other thing I forgot to mention, when we're finished with all this, I'll share these files up on MakeCode and put the links on Canvas so you guys can look at them. And of course, the videos are online too. So I think what I'll try with the other group is actually to do the button pressing business the other possible way that I can think of, just to see which one works out better. Okay, why not? Okay, so this is a little janky, but what I did was, first let's make an array of all the different tiles, and then I'm going to check each one to see if I'm overlapping with it. Okay, now that's silly because am I ever overlapping more than one tile? No, by design. Okay, so the fact that I've got that for loop is it's like I said, it's janky, but hey, it works. It'll work. Okay. Then I'm going to say, all right, am I overlapping with a tile? Well, yes, I'm always going to be overlapping with a tile. Is that tile's data object blah? Well, what data object do I care about? Its state. Okay, and if it's state 0, then what do I need to do to that dude? Change its state to the appropriate thing and change its image. Okay, so let's change its image first. Okay, and I can do this, right? Set values image to, oh, well, actually, which image do I need to switch it to? Depends on whose turn it is. Right? Yes.
You could also, you could do on A button push, you do one, and then on B button push, you do another.
Okay, yes, but what happens if I have a stupid user? They break the game. Well, or accidentally hitting the wrong one. Okay, so that 100% true, we could do that. Okay, but you need to assume that the person using your program is the stupidest person on the entire planet. Okay? Yeah, so the computer's worst enemy is the person in the chair sitting in front of it. Because some moron will do that. Okay? And it's kind of like, well, think about games you play, right? Where, like, there could be like a pit of lava and like a little rock down there that maybe, just maybe, the player can go jump on that rock. Okay, so some player's going to do it, and because of that, what do you have to assume when you're designing the space that's got the lava and the rock? You need to give them some sort of way to get out of it. Either kill them or give them a way to get out of it. Right? So that'd be like a ladder over in the corner or something, or like a box. All right, yes, so assume your user is stupid. Okay, so we need a variable to store whose turn it is. Okay, so let's go back over to the very beginning and let's create that. All right, so I'm going to make a new variable, and I'll call this player turn. Okay, and then under variables, I need to set an initial value, and I'll just make it 0 to start, okay? Or actually, no, why don't we make it 1 for player 1's turn, and we'll alternate between 2 and 1. Okay? All right, so then, back over here, I need yet another if thingy, because I need, if it is player 1's turn, this go? Okay, if it's player 1's turn, what do I need to do? Set the image to the X. What else? Change the player turn. And change the state of the tile that I just flipped so that later we'll need that. Okay, so then that would be under sprites. So we want set item, and then I'm going to duplicate one of these generic value blocks. Set state, to 1. Yes.
What does this generic value block do?
So this generic value is basically, I overlapped with somebody, okay? Value here is going to be one of the things tile 1 through 9. Do I know which one it is? No. I mean, I do because I can look at the game and I know where I'm at, right? But the game, like, what I'm basically doing is saying, okay, give me a list of all tiles, okay? Go through that list. So value is going to take on the, it can be tile 1, tile 2, tile 3, all the way up to tile 9 once I have all 9. Okay, then, is my cursor sprite overlapping with one of those guys? If so, do stuff. Otherwise, if I'm not overlapping with a particular item, do I care? No, don't worry about it, okay? And we've constructed our cursor in such a way that you can only overlap exactly one thing at a time. That makes sense, right? Because it's, okay. Okay, so are we cool so far? All right, so what do I need to duplicate here? I need to take these 3 dudes, because on my player turn can either be 1 or 2. If it's 1, player 1 just made a move. So set the image to an X. We'll say X is player 1. Change the turn to 2, so now it's the other person's turn. And change the state of the thing that we just flipped to 1. Okay? So what do I need to do with these 3 blocks? Need to duplicate this guy, and this guy. Okay? What needs to change in this little chunk? Instead of X, I want, I want O. Instead of the player's turn going to 2, I will need to put it back to 1, and this one would be a 2. Okay, does that make sense? All right, so let's test it and see if the tile flipping correctly occurs. Okay, so I can still move. All right, now if I hit a button here, wrong one, nothing's happening. Why? Because there's no sprites there yet, because I just was lazy. But if I come up here, go ahead. There's no object to overlap, so all of these ifs are false, and so nothing happens. Okay? And the only reason there's no tiles down there is because I was lazy and didn't create the other 3. Okay? I need to go back in and do that. But, all right, if I'm here in the middle and I hit the button, okay, it's got an X. All right, what should happen if I hit the button here again? Nothing. And I'm spamming it, okay? What should happen if I go to any other space and hit the button? Should flip to an O. Okay, did you have a question?
Yeah, how did we get it in terms of coding? How did we get it to where you cannot change it from like, so say a tile.
So I can't flip the X? Okay. Okay, right here. If the state is 0, then we do all of this stuff. Okay, what did we say state 0 meant? Blank tile. You're unflipped. Okay, and because what we did was anytime we flip it, we set the state value to either 1 or 2. If it's already been flipped and I check, is the state's number equal to 0? That's false. And so I don't do any of the if things. Right? And that's how I prevent a player from being able to flip a tile that's already been flipped. Okay? Now, I should say, in some games, you might actually want it to be that they can get flipped back. But not in tic-tac-toe. Okay? So does that make sense? We handled that with that conditional. And notice, by the way, that you see how these are nested? They're not sequential ifs, they're nested ifs. So if the outermost one is false, I never even check the inner ones, right? And if this is false, I never even check that one. Okay, okay, good. So now if I go to any other space, let's test it. And I hit the button, what should happen? And if I spam it, no change. And if I go back and spam that one, no change. X, O, X, O. Okay. So looking pretty good. Yes? All right, excellent. Okay, so we've got a whole lot of stuff accomplished here. Two other things I still need to do. Let's go ahead and duplicate those tiles down at the bottom because I was lazy earlier. Oops. So let's go over here and make 9 more tiles. You sure there's no way to like, yeah. Well, okay, whatever. We'll just do it. That's really stupid.
Oh, so you can duplicate everything in the bracket.
Yeah, but then I'd have to delete a bunch of shit. All right, well, whatever. We're this is like any of you guys remember watching is either Toy Story 1 or 2, I don't remember. And Piggy, the piggy bank is like on the remote control, and they're scrolling through the TV, and then they pass it, and he's like, no, it'll be faster to cycle back around rather than turn around. Kind of the same thing, right? It'd be faster for us to just duplicate everything. If we wanted to be really smart, we'd write a loop to do this, but all right, so tile 7, tile 8, okay, and finally tile 9. Okay, so the only thing we need to fix is the positions. Where should tile 7 be? He should be at x equals 48, y equals 92. This guy in the middle should be at x equals 80, y equals 92. And what about the dude at the right? 112 and 92. Okay, so let's double check that. Okay, good. Now we got the full grid. And okay, works. Okay, so what's the last thing that we have to do? Yeah, win checking. Okay. And that's sort of non-trivial because there's a lot of different ways to win. Okay, so under what condition does somebody win? 3 in a row. Okay, so how many different possible configurations of that are there? Right. Okay, so there are 8 states in which somebody has won, and therefore 16 because it could be either player winning. Okay, so we would need to check 8 things. Top row, all the same. Middle row, all the same. Bottom row, all the same. 3 columns, and then the 2 diagonals. Okay, so that's 8 different configurations, and because it could be either the case that either player wins, really could be 16. Okay, so what we're going to need to do is write a function to basically check all of those possibilities. Okay, now we have made a variable called player turn. All right, so we could also make a another variable called like game state. Okay, and let's say that game state 0 is that nobody's won. Game state 1 is that player 1 has won, and game state 2 is that player 2 has won. Okay, and maybe we could even say game state 4 is that there's a tie, or it's a like a draw. Okay, because the unfortunate thing about tic-tac-toe, right, is that it is possible that you move and nobody wins. Okay, that is mildly annoying that that can happen, but hey, okay. Under what condition can nobody win? Yeah. Nobody gets 3 in a row, okay, but also there are no unflipped tiles. Okay, does that make sense? Okay, so what we need to do is we need to check, how could we check whether or not the top row, let's just start with the top row, has a winner? Yeah, if they're all the same state. Okay, now the trouble with that is, and this is what I mentioned maybe 15 minutes ago when I said this is going to cause us an issue later, what about if they're all state 0? Then nobody's won yet. Okay, so we'll have to take that into account when we design this. All right, so what we could do, though, is under logic, we can check whether or not things are equal. Okay? And we can check, say, for example, whether or not multiple things happen at the same time. Okay, so this would be with the AND block. Okay, so we're actually going to need several of these. And this is going to get a little bit complicated. Okay, so what do we need to check? We need to check for the top row, which 3 items? Which 3 tiles? 1, 2, and 3. Okay, what objects do we need to check from them? We need to check this guy. So we need to check who, tile 1, what data, state, and what number do we want to know if it's equal to? Okay, 1 or 2. Okay, so, all right, so let me say this maybe slightly differently. To tell whether or not somebody's won, let's be as generic as possible about that. When does somebody win? 3 in a row, which means the states for all 3 things need to be the same. Okay, they could all be 1, they could all be 2, they could all be 0, but do we want that one? No. Okay, so what we'll do is let's say, is it the case that tile 1 state is 0, or is, sorry, non-zero? And is it this case that tile 1's, oh, I need more equals blocks here, sorry. Oops. I wanted this one. Yeah, because it's the wrong data type. Scratch is a little bit more forgiving with that, but okay. So I need to know, is tile 1's state as a number the same as tile 2's state as a number? Okay. And, let me duplicate that, is tile 2's state the same as tile 3's state? And I want all of those to be true, okay? So I'm going to put this and, if I can get it to fit there, this. Okay, so this block, which is super wide, is checking, it would be a Boolean. Okay, it's true if all three states are the same number. Okay, but is that quite good enough? No, because what do I want? That any of them is different than, they need to be either 1 or 2, right? Okay, so what I could do is I could say, is the first tile different than 0 in its state? Yeah? And then I could say, is that true? And is all this other crap true? Which is kind of nasty. Okay, now, this hopefully will give you a sense for the limitation of graphical programming. Because is it at all clear what that thing is? No, of course not. Okay, so what I would want to do, well, here, let me go into Python view. I don't think it'll have that there. No, it won't. Yeah, let me just throw it in an if statement here so that we can see it. Okay, so I'm just going to put a lone if statement there. That's not where I want it necessarily, but I'm just going to put it there so that it appears. Okay, the nesting of this is not obvious. Okay, this is the advantage of textual coding, because if I go here, I can see there's parentheses and stuff. Okay, all right, so let's be clear on the logic. One of the tiles has to be different than 0, and all 3 tiles need to be the same values. If both of those things are satisfied, then I have a win situation. Okay? Although I probably should have written this a little differently, because now I have to say, well, who won? But that's okay. All right, well, let's quit here. We'll finish this on Thursday, and I'll give you guys some sort of assignment. Yes?
So when you're doing the subject where you said that is tile or something, you have to go in and do like different statements for like each of the possible winning combinations. So
Yeah, we'd have a shit ton of if then else's kind of things. Right, well, or another way to put it would be, there are 8 things that we have to check. Row, 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 column, 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 diagonal, diagonal. Okay. And is it annoying that there are that many ways to win? Yes, but that's the game. So, c'est la vie. Okay. All right, let me kill the stream here.